Hello everyone, my name is Aaron Jacob. I am an EC student and this is the exploration of the Nuclear Control Simulation Project, a C program designed to simulate a nuclear defense system for the Module Systems Programming. I'll be covering its functionality, design, execution flow that demonstrates the key features of the program. The Nuclear Control Simulation is a client-server application written in C designed to emulate a defense network. It features a central server, nuclear control, and 4 clients, missile silo, submarine, radar, and satellite, connected all by their TCP sockets on ports 8081 through 8084. The simulation runs for 60 seconds, processing threats, issuing commands, and logging events in text files. The program excels in implementing loops, conditionals, logic, inputs, outputs for basic operations, robust server-client networking for all entities, graceful error handling and recovery, safe memory allocation, encrypted data transmission for security, secure logging for audits, detailed codes, comments, and a test mode. Security is paramount and keeps the system operations flowing without the risk of leaking classified intel reports. All messages are encrypted and decrypted by the Caesar cipher using a shift of 3, transforming letters, for example, A to D, by the Caesar encrypt function, preserving non-alphabetic characters as a ciphertext. The Caesar decrypt function reverses this as a plain text, ensuring secure server-client communication. This fulfills the security requirement by making data harder to decipher. Before compiling each C files, in this case I have all the C files into one folder, which I need to set the terminal to a specific directory by typing cd uk_nuclear_simulator. On Mac OS with Visual Studio Code, verify Clang's version by running clang --version. This ensures compatibility with VS Code C/C++ extension package, as Mac OS may have outdated Clang installations. Clang compilation requires the pthread library for threading. Mac OS executables lack extensions for that. The program generates log files for events and text files for summaries, meaning data storing. Now, to compile the C files, use Clang. I prefer to start with the nuclear control server first and then the clients in order based on their port numbers. Notice how the server has only the pthread for compiling. The pthread flag is required only for nuclear control because it uses POSIX threads to manage multiple clients connections concurrently, enabling thread creation and synchronization with mutexes. While the client programs do not use threading, so they are compiled without pthread. To run the program, I suggest to split the terminal into 5 first and then begin typing the server and clients in order based on their assigned port numbers. This way, you won't have to waste any precious time observing the simulation and decreases the chances of getting any errors. Then each C files have their own log files that shows the radar and satellite sending encrypted threat reports to send over to nuclear control server to decrypt the reports in order to send encrypted commands again to the missile silo and submarine to decipher their orders to execute their launching sequence. Everything is set to operate within the cycle of 60 seconds or 1 minute, which I believe is sufficient enough to run the program. After the simulator reaches the threshold, the server disconnects all the clients and the system terminates by itself. Finally, it creates a TXT or text file that summarizes each C file's operation, like total missiles have launches or total threats have detected. Looking back, the program's modular design and error handling ensure reliable concurrency. However, I still see that there is still more room to improve, such as the Caesar cipher could effectively demonstrate encryption better, though real-world applications would require AES installation. Implementing new modes and threads would extend the main functions to generate different locations and coordinate datasets and allowing the user manually play around the simulation. Personally, I would give myself between 85 to 95% due to some errors within the nuclear control summary text file, and modifying the smallest bit of code would result in errors that I could not figure out. Developing this project was challenging and time-consuming and yet rewarding. Above all, this project enhanced my C programming skills, curious to learn more and further understanding in using different compilers.